right, I thought I would do number 19. I'm going to do it both ways, with long division and with synthetic division, so it's going to take a while to do this problem. Here's the problem with this one. It's missing a lot of terms, and when you're missing terms, you have to fill it in. So this would be, I need to write down x to the fourth plus 0x cubed, so you fill in with a 0 for any exponent that's missing. You can't do the division if you don't do this, so I'll have to, it's missing the cube term, the square term, the x term, and then I've got my constant. So now I can go do long division, so I'm going to write down x to the fourth plus 0x cubed plus 0x squared plus 0x minus 1. Okay, and I'm going to divide it by x minus 1. And now remember, when we do long division, the only thing we're really looking at is I'm saying how many times does this, just the x, go into the x to the fourth? Well, it goes in x cubed times. So I say x cubed times x is x to the fourth. X cubed times negative 1 is a negative x cubed. Now remember, when I draw the line, what I'm going to do is subtract. I got to subtract every term, so that negative gets applied to both of those terms. And if you need to go off to the side to do some of the math, do it, because I know some of you were struggling in class. X to the fourth minus x to the fourth would cancel out. That would be 0. I'm just going to draw a line through it. 0x cubed minus x cubed would be, remember, a minus and a minus make a plus, don't they? So that'd be a positive x cubed. That's where some of you were struggling in class yesterday. All right, so now I'm going to bring down the x squared term. That's 0x squared. And I'm going to say, how many times does x go into x cubed? I'm always just taking the x and dividing it into the first term, okay? Well, it goes in x squared times, okay? So x squared times x is x cubed. Remember, once in long division, once I find the number, I have to multiply it by what's out front. The thing about what's out front this time, there's two terms, okay? So x cubed times x is x squared times x is x cubed. X squared times negative 1 is minus x squared. All right, now I got to subtract, just like long division. I have to subtract both of those terms. If you don't remember how to do long division, this section is going to be really hard, so I would go practice some regular long division problems if you're struggling already with this problem. X cubed minus x cubed would cancel out. 0x squared minus x squared would be a positive x squared. Okay, so again, because it's 0 minus a minus, that became a plus. Now I'm going to bring down my x term, and I'm just going to do it like this. That's 0x. Okay. So how many times, I'm going to use a different color for each thing, how many times does x go into x squared? It goes in x times, positive x times. Now x times x is x squared. I also have to say that x times a negative 1 is a negative 1x. And then I'm going to draw my line, and I'm going to subtract both of these. X squared minus x squared is 0, so they cancel out. 0 minus 1x is a positive 1x. Two negatives make a positive. Now I got to bring down my x minus 1. My minus 1 term. Brought down everything else. Oh, look at this. They're the same thing. You could think of it this way. You could just say x goes into, let me pick a different color. X goes into x one time, so it's a plus 1. 1 times x is x, and 1 times minus 1 is minus 1. And if I subtract these two, x minus x is 0. Negative 1 minus 1, those two minuses become a plus. That's also 0. This went in evenly, and here is the result. That's how you do it with long division. Now, with synthetic division, if you remember, what we're going to do is we are going to take all the coefficients, and I've still got to write it out the way that I did up here that I'm circling repeatedly in purple right now. I still got to write it out that way. So let me go to a new slide for that. X to the fourth plus, we had to fill in with 0x cubed plus 0x squared plus 0x, and then it was minus 1, and we're dividing by x minus 1. All right, with synthetic division, one thing that you've got to remember is that we divide by the 0. The 0 is we also know it is the solution, the x-intercept. We divide by the 0 of the term that we're on the bottom, dividing by x minus 1. That means I'm going to set it equal to 0, and I'm going to solve it. What am I going to divide by? I'm going to divide by 1. Another way to say that is if I represent this thing I'm dividing by, this x minus 1, if I were to label it as x minus k, k being the number I'm going to divide by. The x's match up, the minuses match up. Oh, k is 1. Basically, I divide by the opposite thing of what it looks like in that factor. I'm going to divide by 1. So I'm going to divide. When I do synthetic division, it looks a little differently. We write it a little differently so we don't get it confused. We're going to write a bar like that to show that we're doing synthetic division. And then what we do is we take all the coefficients from up here. If it's missing, it's a 1. So I've got to have it for each term. I can't skip any term. So there's a 1 there, a 0 there, a 0 there, another 0, and then at the end I have a minus 1. Now, in order to start, synthetic division goes very quickly, and people tend to like it a lot better than regular division. What you have to do is you have to have something to start with, so you're going to drop down your 1. When I get a number down here in the bottom where I've just moved this 1, I'm going to always multiply by this number out front. So I'm going to say 1 times 1 is 1. Now in regular division you would subtract numbers, but in synthetic division you add them. It's very funky, but it works, okay? So I say 0 plus 1 is 1. Ooh, I got a new number down here. So what I'm going to do with this new number here is I'm going to multiply it by the number out front. I've got them both in green so you can see what I'm doing. 1 times 1 is 1. I write my result here. Anytime I get two numbers in a column above that bracket, that division sign, I add them. So we're always adding. So I'm thinking 0 plus 1 is 1. Okay, so I got a new number down there. I'll underline it in kind of a rust color. So I'm going to take that 1, I'm going to multiply it by the 1 out front. 1 times 1 is 1. I write my result there. Now I got a new set of numbers to add up there. Every time I get these numbers above the bar, remember I'm adding them. 0 plus 1 is 1. Well, I've got a new number there. So what am I going to do with it when I get a new one? This number right here, I'm going to multiply by the number out front. Always, always, that's what I do. 1 times 1 is 1. If you notice, there's no subtraction involved in this at all, is there? Now I've got two more new numbers to add. Negative 1 plus 1 is 0. This is a good thing. When I get a 0 here, that means this divided evenly. There is no remainder. Okay? So, but this is, I can't write this down. It's like, what is this mess? 1, 1, 1, 1, 1. Okay, well, here's what it is. We started with an x to the fourth term, but we divided an x out. So our largest exponent is actually going to be x cubed. Because if you think about it, x fourth dividing x out would be x cubed. You basically always do this. You take these numbers that you've got here and you put them with variables, and you start with one exponent down from what the original exponent was in the problem. It was 4, so I divided an x out. I'll have a cube there. So I've got a 1x cubed, and I got another 1, so that's going to go with the next exponent down. It'll go with the square. You're always just going down by one exponent. This one right here, I'll circle it. That one, I'm on that one. X to the 1 would just be x, so I'm just going to write x. And then I've got this right here. That would be x to the 0. X to the 0 is just actually 1. So basically your constant term is your last term is another way to word that. I could look at it as 1x to the 0. But if you remember, anything to the 0 power is really just 1, so it would be the same thing as saying 1 times 1. So my answer is x cubed plus x squared plus x plus 1. Now if you look, I got the same answers both ways. This one went a lot faster though. There's something else about synthetic division that we're going to talk about in class. And again, I'm trying to get a little of everything on a video, but you can't make up in a 10-minute video for what we do in an hour of class, so I'm going to try to do my best here. Synthetic division is great for this sort of thing. People love it. It makes it go very well, very quickly, right? A lot better. People like this a lot better than they like the long division. We learn both because there's times we might need both. Now there's another use for synthetic division. I'm going to talk about it on the next slide. Let's say, and I'm getting this, actually, this is coming from towards the end of the book. I think it's page 523, but I'm going to check. Okay, here's another use of synthetic division, and I'm going to expect you to know this. This will be on the test. Just telling you, I'm going and pulling some things from different parts of the book and putting them in areas where it makes sense to cover them, because we can only do so many chapters in the book, and we're kind of prioritizing them, but this is something we need to talk about. Synthetic division can also be used to evaluate equations. Now, it works a little different when you evaluate equations with it. I'm going to just pick an example out of the book. I'm just looking at the book. I'm picking actually number 4 off the exercises on 10.4. If I have this equation, m of x equal 4x cubed plus 2x squared plus 3x minus 30. And I want to know, let's say I don't have my calculator handy, and I want to know what m of 5 is. Remember, that means plug in x is 5 and tell me what the y is that goes with it. This is just that's what this notation means. So what I could do is this. I can do synthetic division. Now, when I did synthetic division to factor an equation, to break it down, I was able to, I had to divide by the 0. If you remember that, if I had a factor x minus 1, I divided by 1. Here I just have a number, and I'm just going to divide by that number. So I'm going to do my synthetic division, and I'm going to, just like I did, I'm going to draw that upside down bar there. I'm dividing by 5. I don't change the sign on it or anything like that. I'm not trying to factor something here. And I go pull off all my coefficients. Now I've got to check, I have an x cubed term, x squared term, an x term, and a constant, so there's no terms missing. Remember, you have to have one of every term in order to do synthetic division, and if you're missing a term, you fill in with a 0 in front of that. Like if I were missing the x squared term, I would fill in with a 0 x squared, but I'm not missing anything here. So all I do is copy down 4, and again, if it had been a minus 2 x squared, I'd put a minus 2, but it's a plus 2. You got to take the sign with it. This is a positive 3, and this is a minus 30. Now, this is going to go really fast using synthetic division. I could put this in my calculator, but once I know how to do this, I can almost do it faster than using the calculator, which is kind of cool. So what I do, just like with synthetic division, I drop down the 4, and I say 5 times 4 is 20. Remember, every time you get a number down here, you multiply it by the number out front, and I put my result up here above the bar. Every time I have 2 numbers above the bar, I add the 2 numbers together. 2 plus 20 is 22. Now 5 times 22 is going to be 110. 3 times 110 is 113. Okay, I write it there. Now again, remember, every time I get a number down here, I multiply it by what's out front. 113 times 5, I'll come over here to the side, 5, 6 is 565. I'm sorry, 565, should have written it there. Had one of those moments. And then 565 minus 30 plus 565, that's the same thing as saying 565 minus 30. That's going to be 535. That, if I want to know, if I plug in what is 5 in that function, what's the y that goes with it? The y that goes with it is 535. By the time you type all that into your calculator and then go to your table, that almost goes faster to do it this way. If I've got time, I'll do another one. I'm not sure how I'm looking on the video. I'll try another one really quickly. If you look at, what if you had this one again, f of x equal x cubed plus 7x squared minus 11x plus 4, and I want to find f of 2. Okay, so I write my 2 down, I draw my bar, I copy down, there's an invisible 1 there. I've got to take my 7, my minus 11, and my 4. And it goes this fast. Drop down your 1. 2 times 1 is 2. 7 plus 2 is 9. 2 times 9 is 18. Negative 11 plus 18, same thing as 18 minus 11, that's 7. 2 times 7 is 14. 4 and 14 is 18. Now I can tell you that if I plug 2 into that function, the y value will be this number on the end, 18. Pretty cool.